Hello students, in this video we are going to see about 11th standard chemistry, volume 1, unit 7, thermodynamics. This thermodynamics unit is an important unit and also it is practically applicable unit. So thermodynamics, the word thermodynamics is derived from Greek words. So it can be split into two types, thermo and dynamics. So thermo is nothing but thermo, or we can say thermos. So it is nothing but heat. Dynamics is nothing but flow. So thermodynamics is a branch of chemistry which deals about the heat flow in some processes. So let us consider the importance of thermodynamics. As I said, thermodynamics, which is practically applicable unit, so it has variety of importance in various fields. So the first application, this thermodynamics, it is applicable in our so many day-to-day life processes. For example, to say burning of fuel. So burning of any type of fuel is used to produce heat energy. Similarly, flow of electrons in a conductor or in a circuit, it produces electrical energy. And same way, when we take our body, so many metabolic reactions are taking place which are necessary to produce energy, and that energy is useful for performing so many biological functions. So we can say thermodynamics is the study of transformation of energy. So this transformation of energy can be applicable to these day-to-day life processes, and from that we can be able to make some useful predictions. So that is about the main importance of thermodynamics. And not only it is used nowadays, even in 19th century, some scientists, they tried to understand the principles of steam engine which were operated already, just to improve its efficiency. So just to improve its efficiency, they have analyzed its principles, but the lagging has done there. The lagging is mainly due to the conversion of heat into mechanical work. But after the formulation of the laws of thermodynamics, zeroth law, first law, second law and third law, after the formulation of these laws, they understood the principles in a better way, principles of steam engine in a better way, and based on those laws, we can be able to deduce some important mathematical relationship which is useful for a variety of processes. So that is second application which were used in steam engine. And then this thermodynamics, it is mainly used to evaluate macroscopic, macro means large, so it is used to explain or evaluate the macroscopic particles or properties like work and then Q. Q is nothing but heat. So it is used to evaluate the macroscopic particles or properties, and also it deals with the properties of the system which is at equilibrium. So whenever a process is at equilibrium, we can able to calculate it in an easier manner. So that is about another importance of thermodynamics. And the principles of thermodynamics in a later on condition, it can be improved after the formulation of the laws of thermodynamics. As we know, the first law and the second law, it is dealing about the interconversion of energy. One form of energy can be converted into another form. So such concept was explained in the first law and second law. And even the third law was also formulated, but the third law is mainly used in the calculation of entropy. It's another thermodynamic property, entropy, randomness or disorderliness we can say. So not only it is used in the calculation of entropy, even it is also used in the or it is used to explain the unavailability of the absolute 0 Kelvin. Absolute 0 Kelvin is unavailable actually. So that unavailability can be calculated using the third law. So these are the importance, not only these points what we have written here, but there are so many importance of so many points related important to thermodynamics. And whenever we have a positive side, definitely there will be a negative side. So apart from these importance, thermodynamics also have some limitations generally, not based on the laws. Generally it has some limitations. It has so many natural applications we have seen, but it fails to explain the atomic structure, the molecular structure of a compound, and even the reaction mechanism. So the reaction mechanism in the sense, the rate, the speed at which the reaction is taking place. So the speed of the mechanism or the speed of the reaction was not predicted, or it was not considered under the laws of thermodynamics. That was the major limitation of the laws of thermodynamics. Secondly, it is used to predict whether a product, whether a reaction or a process is feasible. So in thermodynamics always we use the word feasible, not possible. Actually it is equivalent to possible. So directly we won't use the word possible, but feasible. So thermodynamics is mainly used to predict whether a process is possible or feasible or not under some conditions, that is under given temperature, pressure, volume, etc. So just we can able to find out whether that process is possible or not. And also it deals with the equilibrium conditions quantitatively in the sense based on the amount it is explaining, but it fails to approach the kinetic factors. The kinetic approach was lagging under equilibrium conditions. So these are the main limitations of thermodynamics. So even though we have so many importance, apart from that some limitations are also there, but even then it is said to be a useful branch in almost all the fields. Now before seeing about the formulations of the laws like first law, second law, zeroth law, third law, we should know the terms which are involved in thermodynamics. We should be familiar with the terms. So to start the terms, the basic term involved in the thermodynamics, it is system. So before seeing about system, we should know universe type. So we know what is universe. So the universe entirely can be classified into two types. One is system and the other one is surroundings. So first we should know what is a system. So system is nothing but any part of the universe, any part what we are considering. So any part of the universe under thermodynamic consideration, that is said to be a system. For example, to say, so here we are just having an object, inside that we are having a small part, and that small part we are considering. So that small part is said to be a system, and this system can be separated from everything that is present in the universe either by real boundary or it can be an imaginary boundary. So system, a small part which is under thermodynamic consideration, and it is separated by boundary from the surroundings. So that is about the system. To explain the system, we can consider a water. See, a water which is present in a beaker. So here we are considering water. Okay, so this water, what we are considering is said to be a system. Okay, and everything apart from this water or everything apart from this beaker, all over the things, they are termed as surroundings, and this glass wall which is separating water from the other substances, the glass beaker, is termed as boundary. So that is about the basic concept, system and boundary. Now coming to, not only we can say water in a beaker, even a balloon which is blown with air. So that is also an example for system, or any aqueous solution, it is an example for system. Now second one, coming to the other part, surrounding. As we have seen, the small part what we are considering is said to be a system, and the other things apart, everything apart from the system, it is termed as surroundings. And the next term is boundary, which is very, very important. This boundary can be a real part or it can be an imaginary part, but anyhow this boundary, it is separating the system from the surroundings. So these are the three terms: system, surrounding, boundary, what we should know before entering into the thermodynamics. Next we are going to concentrate on the types of system. So the first classification is done based on the physical and chemical properties of the substances. So based on that, system can be classified into two types. One is homogeneous system and the other one is heterogeneous system. Homo is nothing but same. The word homo implies same. So here all the constituents of the system can be present in the same phase. So if all the constituents are under same phase, for example to say if the constituents are entirely solid, then it belongs to solid state. If it is if the constituents are entirely in liquid state, then it belongs to liquid state. Same way we can explain the gaseous state also. So all the constituents are lying in the same phase. For example to say, we can give even atmosphere as an example. As we know, air is a mixture of gases. It consists of this one: nitrogen, oxygen, carbon dioxide, water vapor, rare gases, dust particles, everything. So all these particles are completely miscible with each other. So we can give they are present in the same gaseous phase. On the other hand, the second type of classification is heterogeneous. So hetero, the word implies different. Homo means same, hetero means different. So here all the constituents may be in different phases. For example to say, if a mixture is containing two or more substances, one substance can be in a solid state, the other can be in a liquid state, or even the other can be in a gaseous state. So the constituents are in a different phase. Here the phase what we are explaining, it represents the physical state, matter we can say. And for example to say, to explain this heterogeneous system, we can have a mixture of oil and water. You would have even seen this in your home. So when we just mix oil and water, they are not completely miscible with each other. They stand on separating into two different layers. So it is present in different states. That is about the heterogeneous system. Next we will see the types of system based on the nature of boundary. Next type of classification of system is based on the nature of the boundary. So first classification we have seen based on the physical and chemical properties of the substances. Now the second classification is based on the nature of the boundary. So to explain the types of system, we can have different examples. So first we will concentrate in isolated system. So isolated system is a system which can exchanges neither matter nor energy. Matter in the sense we can say the amount of the substance also, or the mass of the substance we can say. So here it is neither exchanging the matter or energy to the surroundings, or it is not gaining any energy or matter from the surroundings. So there is no exchange at all. Such system is said to be an isolated system. Example, hot water in thermos flask. Here in this case the boundary is sealed and also insulated. So to explain this isolated system, we can have the thermos flask here. So just we are taking any liquid, or simply if you are taking hot water in this thermos flask, here the walls, that is the walls of the flask, it is sealed entirely and also it is insulated, which means no heat is given out from the system, from the inside, that is from the flask, no heat is exchanged into the surroundings, as well as the amount of the substance what we are taking inside the flask, it is not also exchanged into the surroundings. So this thermos flask is a very good example to explain isolated system. Next type of system, closed system. So in the case of closed system, there are some system which is exchanging, or it can exchange only energy but not matter. So just it is transferring energy to the surroundings, or it is gaining energy from the surroundings. So any one is exchanging here, that is only energy is exchanging, not matter. So the amount it is remaining constant inside what we are taking. Example, hot water in a closed beaker. So here just we are taking the hot water, the boundary is sealed but it is not insulated. So to explain this, we can consider either closed beaker, or simply we can consider any water bottle. So here we have taken the hot water inside this bottle, and this bottle is sealed, that is the boundary of the bottle is sealed but it is not insulated. So after some time the hot water, it gets cooled. That means what is happening there? It is just exchanging energy. The heat energy is exchanged into the surroundings. But what about the amount of the substance we are taking inside the bottle? It is remaining constant. It is not exchanging the amount of substance what we are taking. That is about the closed system. Finally, open system. So open system is a system which can exchange both matter as well as energy. Both the things are getting exchanged into surroundings. So to explain this open system, we can have hot water in an open beaker. So like this, we are just having hot water in this beaker, and here the boundary is not sealed, not insulated, simply it is opened as such. So we are just keeping the hot water. After some time what happens? Even the vapor from the surface gets evaporated into the surroundings, as well as the heat energy is also exchanged into the surroundings. So both the things, the vapor gets evaporized and also the heat energy is transferred into the surroundings. So that is about the open system, and almost all the processes taking place in nature, that is based on the open system, as both the matter and energy, they are getting exchanged in this case. So that is about the open system. So these are the three types of systems which are classified based on the nature of the boundary. So the next one is we are going to discuss about the properties of the system. So here, properties in the sense, the properties of the thermodynamics can be explained based on mass or amount, we can say, or the size of the particle. So based on the mass or size, we can able to explain the properties of the thermodynamics. So based on such two concepts, the properties can be of two types. One is intensive properties and the other one is extensive properties. So first let us see what is an extensive property. Extensive properties are the properties in which, actually it is a thermodynamic property, so it is depending on the mass as well as the size of the system. I told you already, mass, instead of mass even we can say amount. So they are just dependent on the either mass or size of the system in which it is present. So that is about the extensive properties. And coming to the intensive properties, just contrast to the extensive properties. Intensive properties are nothing but they are not dependent, or we can say it is independent on both mass as well as size of the system. They are not depending on the amount as well as the size of the system in which it is present. So that is about the intensive properties. So we can give a number of examples for both extensive properties and intensive properties. First, when we consider in extensive properties, the common examples: volume, mass, or number of moles. Instead of number of moles, even we can say amount of the substance, because the SI unit of amount of substance is nothing but moles. So amount of substance or number of moles. Enthalpy, a very important thermodynamic property, enthalpy. It is denoted by the letter H. Entropy. So enthalpy is represented by H. Entropy is represented by the letter S. I told you already, entropy, it's a very important factor. It is nothing but randomness or disorderliness. Next one, free energy. It is denoted by the letter G. Heat capacities. So these are the common examples for extensive properties. Now coming to the intensive properties, those who do not depend on the mass or size, they are nothing but molar volume. The familiar concept what we have studied in the first unit, molar volume, molar mass, density, molarity. These are the concentration terms. To express the concentration of any solution, we can use these terms like strength, molarity, molality, mole fraction, everything we can use to express the concentration. But all these concentration terms are intensive properties. They are not depending on the amount or the size of the particle. So that is about the properties of the system. So they are classified based on the mass or size. Next one, we are going to start the thermodynamic processes. In the introduction itself, I told you it is applicable to wide variety of processes. So we are going to see what are the processes which are going to take place in thermodynamics. So the thermodynamic processes, it is nothing but, first of all, we should know what is a process. So process is nothing but, here we are just going to do some operations. Operations in the sense we are going to adopt some methods, and that method is going to produce some changes. So such changes what the method has produced is said to be a thermodynamic process. For example, to say, we can give the basic physical processes like boiling, cooling, freezing, vaporizing, etc. All these processes are termed as thermodynamic processes. So the types we are going to see. So the first type is a very important type, which is said to be a reversible process. Here, to explain this reversible process, we can just think of this initial state is just converted into a final state, and again the final state is returned to the initial state, and this symbol we use to represent reversible. So it is said to be a reversible arrow. So here we are just doing some changes so that the initial state of the system is converted into a final state. Again we are just adopting some changes so that the final state is returned to the initial state. So we can say a reversible process is a process in which the system as well as the surroundings, they are just restoring its initial state, or the process is returning to the initial state from the final state. Such process is said to be a reversible process. And whenever we find this arrow mark in reactions, it implies that an equilibrium has been established in that case. So we can say, in the case of reversible reactions, both the system as well as the surroundings, they are in equilibrium with each other. We know equilibrium is nothing but the constant condition. So at that condition, the temperature will remain constant, the pressure will remain constant, or even the concentration may also remain constant. That is about equilibrium. So whenever we say reversible, immediately we should think of about equilibrium. Understood? Next one. We should know the conditions for this reversible process. So the first condition, whenever a reversible process is taking place, then the change taking place, the changes what we are doing, the change can be a very small change, or we can say, to explain this small, infinitesimally, not considerable amount. So the changes what we are doing is very small, and also throughout this process the equilibrium condition is maintained. So if a process is adapting these two conditions, then it is said to be a reversible process. On the other hand, the next process just opposite to reversible is irreversible. So irreversible, it is just a single step process we can say. That means initial state is converted into final state, but the final state is not returned back to the initial state. Or in other words, we can say the system as well as the surroundings, they are not restoring the initial state from the final state. So that is about the irreversible process, and throughout this process there is no equilibrium. Even at any instant equilibrium is not established. And also a very important concept, all the naturally occurring process, they are said to be irreversible in nature. For example, to say, we can give the best example, waterfalls. So waterfalls, water is flowing from upside to downside. So water is just flowing like this. So one step process, the flown water cannot get back to the uphill. So it is a unidirectional process. And also all the naturally occurring process are spontaneous. At once it is taking place, they are spontaneous as well as irreversible. So we should remember these two terms when we say reversible, equilibrium; when we say irreversible, spontaneous. So that is about the irreversible process. We will continue with the types of processes. So in the beginning we have seen reversible and irreversible. Those two processes are common processes taking place in thermodynamics. So the other processes are, the next one is again a very important process known as adiabatic process. So whenever we say adiabatic, we should immediately remember there is no heat flow. So no heat flow, or heat is not flowing between system and surroundings. That is, heat is not flowing from system to surroundings or from the surroundings into system. So there is no flow of heat. So that is about no exchange of the heat is taking place. So in such case, the system what we are considering, it should be insulated. If it is insulated, there is no flow of heat. So here in this case, if the work what we are going to done, if it is done by the work is done by the system, then the temperature of the system decreases. On the other hand, if work is done on the system, first case is work done by the system, so temperature decreases. In the second case, if work is done on the system, temperature increases. As I told you, whenever we remember this adiabatic process, immediately you should think over this condition, Q is equal to 0. That means no heat flow, no exchange of heat. So the condition for adiabatic process is Q is equal to 0 or dQ is equal to 0. Either way we can represent the condition. So the next one is isothermal process. Here iso means constant, thermal means temperature or heat, we can say heat. In other words, we can say it as temperature. So in any thermodynamic processes, if the temperature of the system is remaining constant, then such processes are termed as isothermal process. So when we are performing experiments, isothermal experiments, in such case the experiment has to be done with thermostat. We have to use that thermostat in order to maintain the constant temperature. So in such case, the condition for isothermal process is Tt is equal to 0. Next one is isobaric process. So whenever we say baric represents pressure. As I told you, iso means constant. So here in this case, if the thermodynamic process is carried out isobarically, the pressure of the system is kept as constant. So keeping the pressure constant, we can maintain the condition dP is equal to 0. D in the sense change. So change in the pressure is maintained constant for isobaric process. And also the next one is isochoric process. As I told you, iso means constant, choric represents volume. So in some thermodynamic processes, if the volume of the system is kept constant, then such process is said to be an isochoric process. So the condition for isochoric process is dV is equal to 0. Change in volume should be kept as constant. That is about isochoric process. Finally, cyclic process. So from the name itself we can say cyclic, like a cycle. See, the system is starting from its initial state, it is undergoing some change, and finally after performing a series of changes, again it is returning back to the initial state. So initial state it is starting, and again doing after doing a series of changes, finally it is returning to the initial state. So such processes in which the system is returning to the original state, such processes are known as cyclic process. During the cyclic process, we have to maintain these conditions, that is change in internal energy. U is nothing but internal energy. Change in internal energy is kept constant. H, I told you, enthalpy, change in enthalpy is kept constant. P, dP, that is the pressure is kept constant, volume is kept constant, temperature is kept constant. So you just remember all the conditions what we are seeing, that is for adiabatic Q is equal to 0, isothermal dt is equal to 0, isobaric dP is equal to 0, isochoric dV is equal to 0. For cyclic process, all the factors together it is kept constant. So that is about the types of processes. So in the next video we will discuss about the functions of the thermodynamics and also about the laws of the thermodynamics. Thank you.